We'd like to thank the Cloud Native Computing Foundation for sponsoring our podcast from Cloud Native Con in Seattle. Inspired by internet-scale computing, the Cloud Native Computing Foundation advances the development of cloud-native technology and services by creating a new set of common container technologies informed by technical merit and end-user value. You can learn more about the Cloud Native Computing Foundation at cncf.io. Hey, it's Alex Williams of the New Stack here just before lunch at KubeCon Cloud Native Day with Nick Weaver. Nick Weaver of Intel and my friend from Portland, Oregon. How are you, Nick?
My coffee buddy here.
Yeah.
How you been, man?
Good, very good. And we were just chatting a little bit, and we've been following the work you guys have been doing over the past several months and years. And I want to talk about your guys' investments that you're making in different projects that relate to these scale-out ecosystems. In particular, Snap, which is your telemetry tool, and then also Kubernetes, and then thirdly, it was interesting what you're saying, how you're kind of like using these different tools internally.
Totally,
right?
Yeah. I mean, so Snap is our open telemetry toolkit. It's been out for almost a year.
And I hate to interrupt, but tell us why you're investing in Snap. Why telemetry?
So the real point of it is we actually took a step back a couple years back. In an overall strategy, we thought, what are the influential technologies that are come out and going to kind of evolve the next generation data centers? Like, what are the emerging technologies and patterns? And several of them revolved around decision making and scheduling and automation, where a human would have made a decision before. A system or an abstraction provides that kind of decision automated, and so you get a higher level of scale, you get better operational costs. And so we looked at that and said, well, what are the driving factors behind making that stuff happen? And one of the things we came out with was, well, you have to have data. So in order for a system to make a decision, it has to see something and understand something in a way that fits its use case. So if you're a scheduler, you have to see how much compute is available, how much is used for things like admission and booking. If you're doing operational uptime and downtime in an automated fashion, like spinning apps up and spinning them down, you have to have health information or utilization information. And so we went back to the case that telemetry, or the data out of the platforms, out of the applications itself, was table stakes before you could even get to the next order problem around scheduling or automation or orchestration. And so then we looked internally and said, well, what have we done around this? And we realized that we had lots of great solutions, but they were all kind of constrained to single little verticals. Like, here's a really cool tool to get data out of an SSD, or out of a CPU, or out of power and thermal, but none of them work together. They're all kind of on their own. And we thought, well, could we go and build something where we start to get all of Intel behind one flywheel to expose the data in a uniform way that is also designed in a way where it's easy for cloud to ingest? And one thing about Snap is it can sometimes seem like it's a bigger project than it is. It's really specifically scoped to how do I go to one place and get tons and tons of data in a declarative way out of the platform. And then on top of that, on top of Snap, we've been doing some really interesting stuff around that intelligent health awareness, around deeper scheduling. So in our Kubernetes work, so you mentioned Kubernetes, we have work we're doing around Snap on oversubscription and around synthetic workload testing and around bin packing and around using some of our features to actually get some really powerful efficiencies on the hardware using Kubernetes directly. And a lot of this is built right on the back of the data that we're getting out of Snap. And it's getting really, really powerful. And I mean, some of it's not quite out in the open yet.
So the tools are coming out of the data.
Yeah, totally. The tool, but now that we have the data, we're actually building new tools. And a lot of our work in the SIGs around Kubernetes, so our work in the SIG instrumentation, our work in SIG node, around CPU isolation, and a lot of our work with specific customers we're talking to now and partnering with is around driving those efficiencies. And for a lot of customers, that's actually not their first order problem. Their first problem is, hey, how do I spin up Kubernetes? How do I turn this thing on? How do I get my applications running on it? But the next problem, based on what happened with the VMware virtualization, the OpenStack, and all these other patterns we saw in the past, the next thing is going to be, well, how do I run this more efficiently? I spent so much money on hardware, how do I pack it and make it dense and use all the features available? So a lot of our work around telemetry and automation and scheduling is kind of getting towards that problem space, which is the efficiency problem that comes after you hit that productivity of using it. And you mentioned the dog fooding piece as well. So internally, for all the tools I just mentioned, all these things we're working on, we actually have a Kubernetes CI system we built with Jenkins that we use to automate all of our CI tests, and we're having an amazing time with it. So it's funny because a lot of the people I brought in to run that project are experts in automated testing and CI and CD. They worked on the OpenStack automation, on infra, and they're all in on Kubernetes, and there were some little hitches there, here and there. They've kind of ironed out, but the experience has been absolutely amazing. And
what
as
about
a part of it? Well, just the automation, the offloading the decisions, and the work is that you have to port your tests and your structures. We had to port our snap test, for example, to run in a container, to be schedulable. We had to fix the workflow things and fix imaging, and we ran into a lot of those kind of corner case bugs Kubernetes ecosystem still has. But the cool thing is we're able to solve them, and we're eventually going to push those upstream. But the real benefit is we end up with this single CI as a service, basically internally, just for our team and for our projects, right? Where we can quickly add new tests to these projects and just let them run. And like for Snap, for example, we have an interesting problem. We're not just providing software to make it easier to collect telemetry, but we're guaranteeing that the hardware telemetry will work. Well, we have a lot of different hardware at Intel. I've got 8 different kinds of network cards and all kinds of SSDs, all kinds of different models of CPU and different builds and different OEMs, and each one that build our stuff differently. And so we have a huge testing lab with all kinds of variances of all those things, and Kubernetes is running on top of that to cross-test all those kind of things. So we can do a patch to snap or a patch to a plugin. It'll make sure we didn't break across different OEMs and different pieces of hardware. And the level amount of work that would take is huge. And Kubernetes is a huge asset to us to go do that.
Right, so because you can automate so much.
Yes, and the thing is, and the cool thing is, from a strategy standpoint, we're also investing in Kubernetes in the CNCF, so we're a founding member of the CNCF.
Right.
And we actually supplied the hardware for the 1,000-node lab behind the CNCF for testing and stuff. So from an Intel standpoint, we're heavily invested in the CNCF and in the Kubernetes and projects like that, because we feel they're tools that need to mature and grow to help our ecosystem go forward.
You're getting a ground floor look.
Right.
Really. I mean,
and then dog fooding it, and then we find other bugs that we can go help push in. So it's like multifaceted attack to try to make this a better story.
So how are you using Snap with that infrastructure?
So in our CI platform, we fully test and monitor all of our CI jobs using Snap and the performance. And then right now we're just in the productivity portion, right, which is how do we get this thing stood up, how do we automate, how do we get the DSL in the format in a way where the developers are enabled, right? So my Snap developers or my Kubernetes upstream developers are enabled. The next thing we're going to do is, how do I pack more of these tests, and how do I drill more? How do I fully utilize that hardware spin that I already did? So it's interesting because in one part I'm looking at my customers and saying, how do I make their life better? How do I give them the productivity? How do I make good investments? How do I make sure that they see Intel as valuable? And internally, I'm actually going down that same path myself. So I'm kind of, by proxy, looking at these same things and saying, how do I use my own hardware that's Intel in a more valuable way for my own developers? But anything we figure out, our goal is to go push that back in the upstream, to go work with Google and Red Hat and CoreOS and Mirantis and all those great partners we have to drive those things in the community and make sure all the customers get access to those things.
So that cluster is available to anyone to use. Right. And so people will be testing all different kinds of things.
Right. I mean, yeah.
And so then that data then can all be shared as well, and there can be a dog fooding across the community as well, right?
Yeah, and we're not. One thing about Snap is, Prometheus is a really powerful, awesome tool. I'm a huge fan of it, and we're not competing with Prometheus. We're actually working on Prometheus integrations ourselves. So those lab tests don't have to have Snap. We may be monitoring the cluster out of band to ensure that utilization's good or see how it's being used, looking for efficiencies. But the point of the CNCF cluster is that it's an open playground for people that are trying to move the industry forward, trying to improve the story on cloud computing, around cloud native applications. And the investment we made was, let's put some hardware out there so we can kind of seed the ability to test things at scale. And that includes Prometheus, that includes Kubernetes, that includes other companies that are here coming in and testing and proving out what their stuff does. Because the point of the cluster is, how do we let customers know this stuff's possible, right? And when you have hardware and lab in a time to go automate and test and show the results, it brings a level of confidence to the rest of us to go off and try and do and kind of step on top of that and go even further.
So what are you learning what is possible?
Well, I mean, I actually think right now we're in the phase where we're learning what's not possible.
What's not possible?
I mean, we're learning, it's the stuff that came up in the KubeCon meetup last night at Google's office. Storage. There's a lot of work still needs to be done on storage.
Yeah, you're fascinated with that.
Oh yeah, and I'm an ex-storage guy, so I'm always going to be fascinated with storage. but there's a lot of work that needs to be done there. We still internally are seeing issues around image storage and management and some of the Docker runtime stuff. And so I think the cool trick now is in ending this year and the beginning of next year is really finding those holes in Kubernetes that need to be filled, because I think a lot of the big pieces of Kubernetes are getting pretty darn stable and getting to a point where you don't even be adding so many features to it. And so we can apply our engineering efforts to places to kind of flesh out the rest of it. The stability on the imaging, the stability on storage, the stability on deployment and tenancy. And as an ecosystem, as we find those holes and gaps and we go and fill them, we kind of flesh this thing out as a more stable. And internally, we're having a lot of great success on that, especially with our upstream folks. And I don't see our investment in Kubernetes going down. It's just going to get greater and greater as we're going forward. It's just turning into this great central piece of open source software where everybody's getting around and building great things on top of it.
So what does it need? What are you finding? Like, that's part of the fun thing is like, with these types of projects is like, it's like, we've gone this far, but I know we can go this far.
Right.
But what do we need to get to that point? I mean, that's why when you start just seeing like, that's what I find so fascinating about the Lissa project, right? That they're considering, right? Looking forward, and so what are some of the things that you're learning internally that you're saying, oh, wow, we really need to like, advance in this area?
I mean, there's three things I think are going to be pretty huge in 2017. One is I've already publicly said we're working on, which is the efficiency work. So we did a lot of work with VMware about bin packing efficiency with VMs using hardware. We did a lot of work in the OpenStack community around that, and we're going to repeat the same thing, and we're doing that now about how to make sure that running Kubernetes is an efficient action on top of Intel hardware, right? We spend a lot of money to make really great hardware,
right?
And if people don't have ability to use that, that's unfortunate for us, right? People should see value in running stuff on our hardware, so we're pushing that. The two other ones, and these are more of a Nick's personal perspective. Right. I think the deployment, like the stand-up of a cluster, is going to be a really hot button in 2017. Because I think in the other ecosystems that maybe haven't had as much traction or stalled, it always seems to be the one thing is the easy button. The easier something is to try, the stickier it is into your plans and how to go do it, right? So I think, and there's a lot of great work happening in this space, but the ability to deploy kind of that wizard-style next finish model of being able to deploy a Kubernetes cluster and try it and experiment with it and get to understand it, the easier that happens, I think the adoption is going to go way up, and it's also going to be a lot easier for people to plan on how to use it in their business, right?
That seems to get to what Craig McCluskey was talking about yesterday with the need for tooling.
Tooling, yes.
Yeah.
So we're actually internally in my team, this happened almost a year ago, we had a big internal meeting around all this space, not just Kubernetes, but Mesos and others, and we said, what are the biggest gaps out here? And the biggest gap my team came up with is actually tooling. And a lot of the stuff we're releasing, Snap, and some other things coming are actually around tooling. But tooling is absolutely the critical asset that you see inside Google, inside Amazon, inside all these big companies that isn't visible in the product,
right?
But it's totally something they're heavily using internally to support and manage those things.
Right.
I feel like it's a missed thing because a lot of times software companies don't look at it as something that's easy to monetize.
Right.
But it's critical to doing.
So a question I have is just kind of, I've been percolating in my head is like, you have the physical layer, right? And then you have all the VMs right above it. Do you need those VMs?
Maybe. And I think, honestly, the bare metal versus on virtual versus, just hosting on a public cloud is really kind of up to the customer.
Yeah.
And there's customers who have very good reasons to run on top of GCE or Amazon. For example, GCE and Amazon both provide a lot of really powerful application services.
Right.
That if you just put my application there, I can just use those application services. That's pretty awesome. But then there's some customers who are doing like video, or some really intense applications, or have a need for bare metal,
right,
or they're savvy enough and talented enough they can feasibly deploy Kubernetes on bare metal and it's not really that hard for them. They get a huge efficiency boost in pure compute power or pure latency benefits by just running on bare metal. And you got both camps, and it really depends on the customer, their level of maturity, their talent in-house. Our goal is to make sure the bare metal story is one that's definitely out there. Like it should be an option. Whether the customer wants to choose it or not is up to them, depending on the cost benefit. But definitely believe that the ease of install and the efficiency features I was talking about drive that bare metal as an option. So at least they have a choice of that.
Right. Nick, this has been a terrific conversation. Thanks for taking some time to talk. Is there anything else you'd like to share before we go?
I don't know. I think watch Intel and our SDI stuff for future updates next quarter. We got a lot of really cool stuff I'm I'm kind of chomping at the bit to
talk
to go
about
show. Unfortunately, this last round of stuff I didn't work on directly coding, so I can take no credit whatsoever for it. But I'm super proud of the great engineers who worked on it. So we got some cool stuff coming, and definitely would encourage anyone that has some serious questions or concerns on Kubernetes and needs somebody to talk to, reach out to us, and we will be glad to help or introduce people to the right people.
I would love to just talk with you sometime about the intersection of AI and new operations and optimization.
I've actually got the guy you should talk to. He's here, but he's not up here yet.
Okay.
But I've got the guy for you on that one.
Okay, great. Well, thanks, Nick. I appreciate it. We look forward to talking soon.
Okay, talk to you later.
We'd like to thank the Cloud Native Computing Foundation for sponsoring our podcast from Cloud Native Con in Seattle. Inspired by internet-scale computing, the Cloud Native Computing Foundation advances the development of cloud-native technology and services by creating a new set of common container technologies informed by technical merit and end-user value. You can learn more about the Cloud Native Computing Foundation at cncf.io.